Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe the structure of graphite. You should then be able to describe the properties of graphite and then link these to its structure. In the last video, we looked at diamond, which is a giant covalent molecule. Because diamond has a large number of strong covalent bonds, it's got a high melting and boiling point. Remember that diamonds formed from the element carbon, and each carbon atom forms 4 covalent bonds. In this video, we're looking at graphite, which is also a form of carbon. As you'll see, graphite is very different from diamond. Let's start by looking at some of the key properties of graphite. Firstly, graphite has a high melting and boiling point. Secondly, graphite is soft and slippery. And finally, graphite is an excellent conductor of both electricity and of heat. So let's take a look at the structure of graphite and try to explain these properties. As I said, graphite's formed from the element carbon. However, in the case of graphite, each carbon atom forms 3 covalent bonds. The carbon atoms form hexagonal rings, in other words rings of 6 carbon atoms, and I'm showing you these here. Because graphite has many strong covalent bonds, it takes a great deal of energy to break these, so graphite has a high melting and boiling point. The hexagonal rings of carbon atoms are arranged in layers, and we can see these layers here. There are no covalent bonds between the layers, so the layers can slide, and this makes graphite slippery. So we've now seen why graphite has a high melting and boiling point and why graphite is slippery. So let's look now at what makes graphite such a good conductor of electricity and heat. Remember that graphite's formed from carbon atoms, and I'm showing you the structure of a carbon atom here. As we said, each carbon atom forms 3 covalent bonds to 3 other carbon atoms like this. Now, as you can see, that means that each carbon atom has a single electron in its outer energy level that's not in a covalent bond. These electrons are released from the carbon atoms, and scientists call these delocalized electrons. I'm showing you the delocalized electrons here. Now, the key fact is that these delocalized electrons can move. This means that they can conduct thermal energy, in other words heat, and also electricity. Now, it's really important to remember that graphite is based on the element carbon, so graphite is not a metal. However, graphite's similar to metals, as both graphite and metals are good conductors of heat and electricity, and that's because both graphite and metals have got delocalized electrons that can move. We're going to look at metals in a later video. You'll find plenty of questions on graphite in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you should be able to describe the structure of graphite. You should then be able to describe the properties of graphite and then link these to its structure.